inertial mass and gravitational mass. One may determine the mass of a body by measuring the acceleration produced on it with a known force, F equals to ma. That implies m equals to F by a. The mass thus determined is called inertial mass.
Here over a plank, a body of mass m is kept. When the plank is pulled with certain acceleration a, immediately the body also acquires the same acceleration a but in opposite direction. That's why it moves in this direction and falls onto the floor. You see here, this is the acceleration a. If the force applied on the mass is F, then its inertial mass can be calculated according to the formula F is equal to ma. That implies m is equal to F by a.
To measure it, the body should be in accelerating motion. Thus, it is hard to measure the inertial mass. Alternatively, the mass may be determined by measuring the weight of the body. That is, W equals to mg. That implies m equals to W by g. The mass thus measured is called gravitational mass. While measuring it, the body should be at rest. Therefore, it is easy to measure the gravitational mass. Practically, inertial mass is always equal to gravitational mass. Think, between the two, which one would you prefer while measuring the mass of a body? While the earth is orbiting the sun, it spins about itself. Now, let us discuss the variation of g due to spinning of earth. Effect of spin of earth on g. Due to spinning of earth about itself, careful measurements have shown that earth is not a perfect sphere, but an ellipsoid bulging at the equator and flattening at the poles, the equator radius exceeding the pole's radius by 21 kilometers. The value of g varies with radius of earth as g equals to gm by r square, that is, g directly proportional to 1 by r square. Hence, the value of g is less at equator and more at poles.
Here, this is the earth which is spinning at a high angular velocity. While spinning, you know, the axis of rotation passes through the poles. You see, the particles at the equator are at more distance from the axis, and the particles at the poles, they lie on the axis. That's why the centrifugal force is more on the particles at the equator and that is less on the particles at the poles. That's why due to the centrifugal force, the equator is pulled like this. So you see here the equator region is bulged and the poles region is flattened. That is, due to spinning, the earth shape is not in a perfect sphere.
Think what happens to your weight when you go to poles from equator. While going from equator to poles with the change in latitude angle, the value of g changes. Let us discuss it now. A body of mass m is taken at P on the surface of the earth. P makes an angle phi with the equator at the center of the earth, which is the latitude angle. The value of g varies with the latitude angle as g1 equals to g minus r omega square cos square phi. Here r is the radius of the earth, omega is its angular velocity. You can learn the derivation of the equation in your higher classes. At equator, phi equals to 0. Thus, g1 equals to g minus r omega square cos square 0. Here cos 0 equals to 1. Thus, g1 equals to g minus r omega square, that equals to 9.78 meters per second square. At poles, phi equals to 90 degrees. Thus, G1 equals to G minus R omega square cos square of 90 degrees. Here cos 90 is equal to 0. Thus, G1 equals to G, that equals to 9.83 meters per second square. That is, G changes from place to place on the surface of the earth. Thus, we consider the average value of G as 9.8 meters per second square. Can you think of the values of G at different latitude angles considering R omega square equals to 0.05 meters per second square? Now, let us discuss gravitational potential energy of a body on a planet.